In 11.3, we're going to learn more about angles, vertical, supplementary, and complementary angles, parallel lines and angles associated with them, measures of interior and exterior angles of polygons. Vertical angles are created by intersecting lines and are a pair of angles whose sides are two pairs of opposite rays. What that means is angle 1 and angle 3 are what we call vertical angles. Angle 1 and angle 3 are vertical angles. That means their measure is going to be equal to one another. They are congruent. So the measure of angle 3 is congruent to the measure of angle 1. Furthermore, angle 2 and angle 4 are also vertical angles. Angle 2 and angle 4 are also vertical angles, and that means the measure of angle 2 is congruent to the measure of angle 4. Supplementary angles are angles whose sum adds up to 180 degrees. So if I take 140 degrees, add that with 40 degrees, I get 180 degrees. So 140 degrees plus 40 degrees gives us 180 degrees, which means the angles are supplementary angles. They add up to 180 degrees. Similarly, 50 degrees plus 130 degrees also adds up to 180 degrees, which is actually a straight angle. So 50 degrees and 130 degrees are also supplementary angles. In the last drawing, I take 180 minus x degrees and add that with x degrees. It does sum up to 180 degrees and therefore is also supplementary angles. Complementary angles are angles whose sum add up to 90 degrees. 60 degrees plus 30 degrees yields 90 degrees, so 60 degrees and 30 degrees are complementary angles. 70 degrees plus 20 degrees again adds up to 90 degrees, so 20 degrees and 70 degrees are complementary angles. In the last drawing, if I take x degrees plus 90 minus x degrees, the sum will still be 90 degrees. So x degrees and 90 minus x degrees are also complementary angles. Line N and line M is cut by a transversal line P. Angle 5, 6, 4, and 2 occur in between line M and line N, so they're known as interior angles. Angle 3, 1, 7, and 8 occur outside the line M and N, and they're known as exterior angles. Alternate interior angles are pairs of angles that occur on the inside of the line M and N. So angle 5 and angle 2 are known as alternate interior angles. Similarly, angle 4 and angle 6 are also known as alternate interior angles. Alternate exterior angles are angles that occur outside of the line M and N. Angle 3 and angle 8 are a pair of alternate exterior angles. Angle 1 and angle 7 are also alternate exterior angles. Corresponding angles are a pair of angles that correspond to the same side of the transversal P. Angle 1 and angle 2 are corresponding angles. Angle 3 and angle 4 are corresponding angles. Angle 5 and angle 7 are corresponding angles. And finally, angle 6 and angle 8 are corresponding angles. If any two distinct coplanar lines are cut by a transversal, then a pair of corresponding angles, alternate interior angles, or alternate exterior angles are congruent, if and only if the lines are parallel. Let's consider the lines M and N. And let's suppose line M is parallel to line N, and we'll cut it by a transversal, the line P. According to the theorem, it says alternate interior angles are congruent. This angle is congruent to this angle. And finally, these two angles are congruent with one another. Alternate interior angles are congruent. Alternate exterior angles are also congruent. This alternate exterior angle is congruent with this angle, and this alternate exterior angle is congruent with this angle. Corresponding angles are congruent. This angle is congruent to this angle. This angle is congruent to this angle. This angle is congruent to this angle. And finally, this angle is congruent to this angle. Also note that since M and N are parallel, and these are vertical angles, this angle is equal to this angle, which is the same as this angle and this angle. Since these two angles are vertical angles as well, they are congruent, and therefore these are congruent as well. The sum of the measures of an interior angle of a triangle is 180 degrees. If I take the measure of angle A plus the measure of angle B plus the measure of angle C, that forms a straight angle of 180 degrees. In the framework for a tire jack, the figure ABCD is a parallelogram. If angle ADC of the parallelogram measures 50 degrees, what are the measures of the other angles of the parallelogram? We know that the line segment AB is parallel to the line segment DC. And the line segment AD is parallel to the line segment BC. The measure of angle D is equal to 50 degrees, and that is an alternate interior angle with angle 2. So the measure of angle 2 is also 50 degrees. Since 50 degrees is a corresponding angle to this angle, this must also be 50 degrees. Notice that 50 degrees and measure of angle 3 are supplementary. They have to add up to a straight angle. So the measure of angle 3 is equal to 180 degrees minus 50 degrees. And the measure of angle 3 must be 130 degrees. Since the measure of angle 3 is an alternate interior angle to angle 1, we know that the measure of angle 1 is also 130 degrees. In the figure, line M is parallel to line N, and K is a transversal. Explain why the measure of angle 1 plus the measure of angle 2 is 180 degrees. the measure of angle 1 has to be equal to the measure of angle 3 because angle 1 is a corresponding angle to angle 3. The measure of angle 3 plus the measure of angle 2 must be equal to 180 degrees because they form a straight angle. Since the measure of angle 1 is equal to the measure of angle 3, we can actually replace the measure of angle 3 with the measure of angle 1. So the measure of angle 1 plus the measure of angle 2 is 180 degrees. The sum of the measures of the interior angles of any convex polygon with n sides is given by the formula n minus 2 times 180 degrees. The measure of a single interior angle of a regular n-gon is n minus 2 times 180 degrees over n. This formula gives us the sum of all of the interior angles. This formula gives us the angle of just one interior angle. The sum of the measures of the exterior angles of a convex n-gon is 360 degrees. If we extend the line segment from each side of the polygon and add up beta 1 plus beta 2 plus beta 3 plus beta 4 plus beta 5, we know that the sum of those exterior angles has to be 360 degrees for how many exterior angles there are. Find the measure of each interior angle of a regular decagon. Recall a decagon has 10 sides, so n is 10. To find the sum of the interior angles, we'll use the formula n minus 2 times 180 degrees, and this gives us 10 minus 2 times 180 degrees, which is 1440 degrees. So this is the sum of the interior angles of a regular decagon. Now if I want to find just one interior angle, I will take and use the formula n minus 2 times 180 degrees over n. We already know the numerator is 1440 degrees, and we'll divide that by 10, which yields 144 degrees. So the interior angle of a decagon is just 144 degrees. Find the number of sides of a regular polygon, each of whose interior angles has measure 175 degrees. I know that the interior angle measure is given by the formula n minus 2 times 180 degrees over n, and we're going to set this equal to 175 degrees. Multiply both sides by n. I have n minus 2 times 180 degrees is equal to 175 degrees times n. Distribute the 180 degrees into the expression. 180 degrees n minus 360 degrees is equal to 175 degrees times n. We'll add 360 degrees to both sides and subtract 175 degrees times n to both sides. This results in 5 degrees n being equivalent to 360 degrees. Divide both sides by 5 degrees. And n equals 72. So we have a polygon with 72 sides. Lines L and K are parallel, and the angles at A and B are shown. Find X, the measure of angle BCA. For this problem, we'll extend the segment BC, and we will extend it to the line K. Let's say it meets the point D on the line K, and now we have the line BD is a transversal to line L and K. And recall that L is parallel to K. Since L and K are parallel, then angle B is an alternate interior angle to angle D, so this angle is the same as this angle. We also have a triangle that is formed, triangle ADC, and we know that the sum of the interior angles must be 180 degrees. So the measure of angle C plus 60 degrees plus 80 degrees has to yield 180 degrees. The measure of angle C plus 140 degrees is equal to 180 degrees. Solving for the measure of angle C, we have that it's equivalent to 40 degrees. So angle C is 40 degrees. The line BCD forms a straight angle. So the measure of angle X plus the measure of angle C is equal to 180 degrees. We know the measure of angle C was 40 degrees, so the measure of angle X plus 40 degrees is equal to 180 degrees. Therefore, the measure of angle X is equal to 140 degrees.